So I thought I'd do a recording of how I solve this using the z-scores and all that. So the first thing you want to do is identify the claim. So the high school officials claim that at least 85% of the students who have graduated from school have received a college degree or enrolled in a college program. Um, so that's what the school officials are claiming, right? So what we really should write is the claim, and we should write it in English. And I won't bother to write that here, but what I really would just underline, or why don't I underline it? So here's the claim. Okay, so we've identified that now. So we're gonna try to see if it contradicts it. So now for our two hypotheses, well, the null hypothesis are, in this case, I think it'd be best to write the null hypothesis as the school officials claim, that at least 85%. So it could be 85% or more. So to disprove that, we have to show that a sample has a proportion that's less than 0.85. Okay, so that's a left-tailed test. So then the next step is we got to calculate a test statistic. So we know that based on to backtrack a little bit to the central limit theorem, we know that the school officials are claiming that 85% or more graduate or go on to get a college degree or of one sort or the other. So there could be some variation. I mean, if you think back to the confidence intervals, right? It could be anywhere in this range, and actually, we don't care if it's above that upper cutoff. We only really care about that lower cutoff. So we want to say, does any sample, so the sample of 60 individuals, is that far enough away from 0.85 to something more than just random chance, random selection behavior happening? So, as we've always done all this term, when you talk about a distribution, you want to think about its center and its spread. Well, the center is our PO number, what the school officials are claiming, and then the spread, because it's the normal distribution, we need a standard deviation. So the standard deviation is found by taking the square root of the 0.85, because we're saying that's the perceived center, times 1 minus 0.85, which is 0.15. And because we're dealing with samples of size 60, there's 60 people that they interviewed. So you're going to have to calculate that. So when I did this, I came up with, let's see, so 0.0461 is the standard deviation. Now, we could, because this is a normal distribution, it's not necessary to conduct this, and I'm going to do another one where I streamline this. Right now I just want to give you some background. We could set up a 68, 95, 99.7 rule kind of situation, because it is a normal distribution. Central limit theorem tells us that. If I add the standard deviation to 0.85, that's going to be what is that, 0.8961, and if I subtract it from 0.85, let's see, 0.85 minus 0.0461 is 0.8039. Okay, so that covers, I know based on the central limit theorem, that 68% of all the samples of size 60 will fall in between that range. And we could keep going with it. I mean, let's do this. So this sample had 47 out of 60 graduates that were going on to pursue an education. So p hat for the sample is 47 over 60. And since we're working with decimals, let's make that a decimal. So 47 divided by 60, I got 0.78. So 0.783. So looking at this 68% mark-offs that I did, that that sample proportion is outside that 68% range. And maybe there's a case here, and that's what significance testing will help us figure out, is how likely is it to get a sample that far away from 0.85 if 0.85 is a center. Okay, so let's step back a little bit here now to get that theory out of the way. So we know the claim is that the school officials say that at least 85% graduate from college. So that's my HO. And we're going to disprove that by saying that it's actually less than 0.85, trying to show how likely is it to get a sample that low, that far away from the mean. So the next thing we're going to do is we're going to calculate a z-score. So the measure in question is the p-hat value of 0.783. And we're going to subtract our center, the mean of 0.85. Then we have to divide it by the standard deviation, and we already did that, 0.0461. Now, one mistake that people will make, they won't use the PO number, the center, for the standard deviation. They'll go ahead and try to use the sample result to get the standard deviation, because that's what we did when we did confidence intervals. The different technique, because we're saying here's the center. Let's see how the samples vary around that center. Okay, so make sure you use the whatever number you write here in PO, and notice that these are both the same number. That's what you're going to use to calculate your standard deviation. So if I calculate this, I'm getting, let's get a pen. I'm getting negative 1.45. So that is my test statistic. Okay, so I've done the claim, I've done my two hypotheses, I found a test statistic. Next, we got to either find a critical value or we're going to do a p-value, and I'll do that next. So I'm using that little mini table on the bottom of the z-score table in the textbook, and I have my HO. If you look back a minute, you'll see my H1 was p was less than 0.85. So this is a left-tailed test. So to get that critical value, we got to find out what the level of significance is in this problem. And as we read through this problem, they don't tell us. They don't tell us to use a level of significance. So a good rule of thumb is use 5%. That's typically what most reports use. So we've got a left-tail test. We've got a level of significance of 0.05. So our critical value of z is negative 1.645. So here's what's going on. We know with z-scores, the mean is 0. We've got this cutoff of negative 1.645, and we got a z-score of negative 1.45, which isn't out as far away as that critical value. So what that tells us is that's within that range. Whatever, we decided on a 5% level of significance, so we're saying anything in this range we can't reject HO. As I've said in other videos and I've written, if you're in this range, you can't reject HO. HO is happy because it can't be rejected. If you get out in this other range, out beyond the critical value, that's called the rejection region. And you reject HO. Well, our test statistic isn't out that far. So we can't, well, this is where we're going to go with this, is we can't reject HO. And we'll talk about what that means here in a second. I would also like to do this with the p-value approach, okay? So I've already decided I'm not going to reject HO because of the critical value. So if I go with a p-value approach, let me get my normal curve table. So I'm looking for the p-value. I know it's a left-tailed test, so I'll be able to just use the table value. So I'm looking for a z-score of negative 1.45. So let's see, negative 1.45. So that is I'm on the wrong line, right there, 0.0735. So that tells me that the probability of getting a result that far away, 0.0735 I think I said, is about 7%. Now, if we go with a 5% level of significance, this p-value is larger than 0.05, so we can't reject HO. There's too big a chance. Another thing about p-values, it's the chance, and you'll see more about this later next week. It's the chance that we're wrong if we decide we are going to reject HO. Okay, so there's a 7.35% chance we're wrong if we say, yep, HO is wrong, the school officials are wrong. And what the level of significance pulls us back and says, okay, if you have less than a 5% chance of being wrong, you can say HO is incorrect. We're going to reject it. Okay, and since we don't have it, we can't reject HO. So that goes just like what we did with the critical values. We couldn't reject HO. Okay, so there's two different ways to do it. I don't care which way you do it. Software will tell us p-values very easily, and you're going to see that in some other videos I'm going to post how to use software to do this. Okay, so now let's pull this all back and wrap up a conclusion. So we decided that we couldn't reject HO. So what does that mean? How do we word this to sound like we know what we're talking about? So I just posted this flow chart, came from another textbook in the Moodle portal this week, or today actually. It's Saturday. So I initially said that this was the claim, that HO was the claim. Okay. So if you use a flow chart, does the original claim contain the condition of equality? Well, we said equal to at least 85 or greater, so that's where we're doing this. So whereas this one was less than, this was kind of contradict the claim, so that's not what we want. This was the claim. So yes, we did have a condition of equality. Did we reject HO? No, we didn't. So the way we word this conclusion, we say reject HO, but we need to add more to that to put it in context of the claim. And one way to word that is say there's not sufficient evidence to warrant the rejection of the claim that 85% or more of their students go on to post-secondary education, or whatever they word it. Okay, so this will give you a way to sound statistical much more than just reject HO. Okay, so I hope that helps you out.